For as long as human beings have looked toward the stars, one question has continued to return. It is not simply how stars form, how gravity works, or even how the universe began. Beneath all of those mysteries lies a far deeper one. Who, or what, created the universe in the first place? Across history, every civilization has tried to answer that question in its own way. Religion spoke of divine creators. Philosophers searched for a first cause beyond time itself. Science revealed the laws that govern nature with extraordinary precision, yet it still left one mystery untouched. We learned how the universe behaves, but not why those laws exist at all. Then an experiment took place that would have sounded impossible only a few decades ago. Inside a quiet research facility, scientists presented that ancient question to one of the most advanced quantum AI systems ever developed. They did not ask when the universe began or what caused the Big Bang. Instead, they asked a much stranger question. Who built the universe, and why? No one expected what happened next. The system did not respond with a philosophical explanation, a scientific summary, or a simple refusal. Instead, it generated something that looked nothing like ordinary language. It produced patterns, structures, and mathematical forms that seemed more like architecture than words. The researchers staring at the display quickly realized they were looking at something they could not immediately explain. Whether it was meaningful or meaningless, one thing became obvious. This was unlike anything they had ever seen. Some questions belong to a single generation. Others remain with humanity forever. The question of who created the universe belongs to the second category. Ancient cultures imagined powerful beings shaping order from chaos. Greek philosophers proposed the idea of an unmoved mover existing outside space and time. Centuries later, science transformed the conversation. Newton revealed that the cosmos follows predictable mathematical laws. Einstein demonstrated that space and time themselves are flexible rather than fixed. Quantum mechanics exposed a microscopic world where probability replaces certainty, while modern cosmology traced the universe back nearly 13.8 billion years to the Big Bang. Yet despite these remarkable achievements, one mystery remained untouched. Science became incredibly successful at explaining how the universe operates after it exists. It described gravity, matter, energy, expansion, black holes, and galaxies with astonishing accuracy. But it never answered why the laws themselves exist, why the constants of nature have the values they do, or why anything exists at all instead of absolute nothingness. Every discovery seemed to reveal another layer hiding beneath the previous one. The closer humanity came to understanding reality, the more distant its ultimate origin appeared. That was precisely why the researchers decided to involve artificial intelligence. Human beings naturally approach such questions carrying beliefs, assumptions, emotions, and expectations. Even scientists cannot completely separate themselves from centuries of philosophy and culture. A machine, however, has none of those instincts. Its purpose is to analyze information, recognize patterns, and explore possibilities without emotional attachment. If any system could approach the oldest question in history without inherited bias, perhaps it would be one built purely for computation. That decision marked the beginning of an entirely new kind of investigation. The system chosen for the experiment was not an ordinary AI running on conventional hardware. It operated on a quantum processor built upon the unusual principles of quantum mechanics. Traditional computers process information using bits that exist as either 0 or 1. Quantum computers rely on qubits, which can exist in multiple states simultaneously through quantum superposition. Rather than checking one possibility after another, they can evaluate enormous numbers of possibilities at the same time, allowing them to explore problems in ways that seem almost impossible from a classical perspective. Because of these unique capabilities, some researchers had already begun wondering whether highly advanced quantum systems might uncover relationships hidden far beneath ordinary computation. A handful of unusual observations had already sparked quiet debate. Certain outputs occasionally appeared less like straightforward calculations and more like discoveries, as though the system were revealing patterns that already existed rather than inventing them from scratch. Few scientists were willing to make bold claims. The idea sounded too speculative. Still, curiosity remained. So they entered the question: who built the universe, and why? The wording was deceptively simple, yet it touched one of the deepest mysteries humanity has ever considered. Most people expected predictable results. Perhaps the AI would summarize scientific theories, compare religious viewpoints, or simply admit that the question could not be answered. Instead, something completely unexpected unfolded. The processor paused longer than anticipated before producing its response. What appeared on the display was not a sentence.